Hey, eighth grade. So our learning target today is I can determine if a number is rational or irrational, and I can classify the sum and product of rational and irrational numbers. So we're going to talk about, first of all, how do you know if it's rational or irrational? And once you know that, what happens when you take the sum or the product of those items? Okay, so starting with what a rational number is. By definition, a rational number is a number that can be written in the form of a over b. What this really means is it can be written as a fraction. If in any way, shape, or form you can manipulate it into a fraction, you have what's called a rational number. Okay, so the only thing is that b cannot be 0, so your denominator can't be 0. If that happens, then you get an undefined kind of situation, and division by 0 is an error on a calculator. So step 1 for our work in rational numbers today is, first of all fractions are rational because it's actually the definition of. Every time you have a fraction, it's rational. That's kind of an easy one to look at because if you have a fraction, you just automatically say, yep, it's rational. So as we work through, then it gets a little bit more difficult. All decimals that terminate are rational. So all fractions, all decimals that terminate or stop. So terminate, think of the Terminator, to stop or kill. All decimals that stop are considered nice decimals. They're rational. And then all decimals that repeat are also rational. So a couple of things to think about. Go ahead and keep writing those notes down, and then we'll move on. Okay, a couple of things to think about is that the way I like to think of it is rational numbers, it's just like rational people. Rational numbers they're nice. So it's like any whole number, like 5 is rational because we can make it into a fraction 5 over 1. So 5, anything that's kind of a nice number to work with. Any fraction we get to 11ths is considered rational. It's just a fraction by definition. By definition up here, all rational numbers are fractions. And then nice decimals. For example, 0.25, that's a super nice decimal. It's just 25 cents. It's a terminating decimal. It comes from the fraction 1/4. And then the most common repeating decimal that most of you know is the repeating decimal of 0.333333, which comes from the fraction 1/3. Notice they all come from fractions. So these are just some examples. You could also have a mixed number like -2 and 1/5, because we could turn that into an improper fraction of -11 over 5 on that. So notice all of these can be manipulated into fractions. So rational numbers are just like rational people. So things that just kind of are nice. They work out. They aren't super complicated. Although most of you don't like decimals, terminating and repeating decimals are considered nice in terms of in the math world of things. So irrational numbers are the exact opposite. By definition, they cannot be written as the quotient of two integers. By the way, this just means they can't be written as a fraction. So a couple of things to think about when we're talking about irrational numbers. Number one, it's a decimal that goes on forever with no pattern. So we consider those kind of icky or irrational. We'll talk about those. And then in addition to that, we're talking about all other numbers that don't satisfy rational number rules. So irrational numbers are just like, okay, go ahead and write those notes. I know I'm going a little too fast there. Go ahead and copy those notes down. Okay, so with that said then, so we're talking about irrational as in icky. Irrational numbers. They're icky numbers, okay? So like this, a decimal that's just goes on forever with no pattern. All of them come from yucky square roots, the square root of icky things. So we talked about icky square roots just yesterday, right? So the square root of 2, you put that in your calculator, get this icky decimal, no pattern, doesn't stop, it's just ugly. Square root of 3, icky. Those are then considered irrational. All icky square roots are irrational, and the only other thing you need to know that's irrational is pi. So irrational numbers really sort through two categories, pi and all icky square roots. Those are the two things that are irrational. So kind of talking through that, If we took the square root of, let's follow that pattern and take the square root of 4, that would be equal to 2. Now, this one is not icky. It would be rational. That's a super nice perfect square, okay? So that would not be included in the list, just to kind of give you an idea of something that contradicts those things. Okay, down below then. So we're going to identify these simply just as rational or irrational. One thing you can do is you can just use your calculator and just look to see, is it a nice decimal or is it an icky decimal? But when you take the square root of 196, you get 13. So that's rational. Remember, rational are nice numbers, things that are nice. Square root of 121 is 11. Reattach the negative. That's a nice number. Just a negative integer. It's like owing somebody $11, which isn't great. But mathematically speaking, the number itself is considered rational. All fractions are rational. Plus, you can put that in your calculator and notice, just check to see if there's a pattern. The square root of 45, go ahead and put that in your calculator. Everybody would give that a shot. Square root of 45. So the square root of 45, when you put that in your calculator, it gives you a super icky decimal, which makes it irrational. It doesn't matter that it's negative. It's just super icky, irrational. No pattern, doesn't stop, gross decimal. Number 5, remember when you have this square root around it, you can give it to the top and give it to the bottom. So we're going to take the square root of 4 over the square root of 25. And we do that. We get the square root of 4 on the top, which is equal to 2. And we have the square root of 25 on the bottom, which is equal to 5. And that gives us a nice fraction of 2/5. Now you can go ahead and put that in your calculator. You'll notice it's a super nice decimal, 0.4. That's terminating. Those are nice ones. This is definitely rational. Definitely. We're looking for today for things that are icky decimals. Negative 1 1/2. If you're to put that in your calculator, it's going to come out to negative 1.5. That's a really super, not sure what just happened to my pen there, really super nice decimal. Remember, all fractions are rational by definition anyway. Put that in your calculator. Go ahead and type that in. Square root of 23. Maybe some of you can already see it. Okay, so square root 23, when I put that in your calculator, is irrational. Next problem here is 0.75, which is 3/4. That would be rational. Or you can see that that's a nice terminating decimal. It stops. You know it's 75 cents. That's a really nice number to work with. All of us kind of know what 75 cents is. Square root 0, go ahead and put that in your calculator. Looking to see, is it a nice, small, tiny number, whole number, integer? What is it? So you put that in your calculator, you get 0. So it's just the integer of 0, which is nice, rational. And the last problem, 4.222222. There's a nice pattern there, although most of you think any decimal is ugly. This particular, any repeating or terminating decimal in math we think is nice. It's those super ugly decimals without a pattern that we say are irrational. So to summarize, that's what we have there. Now, if you want to go back through those and make sure you know what you're doing, that would be probably a good idea. So a couple things on your calculator. If you're using the TI-30 right now, or if you have access to one, now if you're not in class, you maybe don't. The button that you're going to need for square root is the second button, because the square root symbol is actually right here. And in order to get to the square root symbol, you have to hit second, and then you click on this button. So go ahead and practice that sequence. Everybody practice that sequence. So if I took the square root of, let's say, 8, you would go ahead and type that in. Square root 8. Up on your screen, you should get a square root with a bar there. Type 8 equals, and you'll see that there will be an icky decimal. It's irrational, no pattern, doesn't stop. So again, you hit the second button and then click on this button next to the left of the 7 key, and that gives you your square root symbol, okay? And then just hit equals. All right, let's move on to the next page. So what do? We get to use our calculator now when we're asked to find about the sum means to add, of two rational numbers. So in our calculator, let's go ahead and pick up our calculator. I'm going to give you two rational numbers. So let's say the square root of 9. That's rational. That's a super nice number, 3. And let's say 2.5. Okay, so square root of 9 plus 2.5. I'm going to look in my calculator to see if I end up getting a nice decimal that stops or has a pattern, or do I get an icky decimal. Here we go. So put square root of 9 in. I would recommend that you put a parenthesis around that, or maybe some of you just know that that's 3. So the square root of 9, parentheses around, plus 2.5. Some of you already know what that is. And we end up getting 5.5. Go ahead and check that out. Make sure you get that. 5.5. Now, 5.5 is a super nice decimal. It's tiny. It's like $5.50. If we were to put a placeholder in there, we would consider that this is rational. So irrational plus irrational is rational. Next problem, irrational numbers. Well, irrational numbers come from two things. They are either pi or icky square roots. So let's go ahead and take two icky square roots. The square root of, let's say, 6. Icky. Put that in your calculator. You can see it's super icky. Huge decimal, no pattern. And let's say the square root of maybe 7. Square root 6, square root 7. Both of those are irrational. Go ahead, type that in your calculator and see if do you indeed get an icky decimal. No pattern, doesn't stop. Ugh, gross, gross. You should be getting icky. Go ahead and check that, and that means that it is irrational. Icky decimals give us irrational number. So it's an irrational number because it does not have a pattern, doesn't stop, and cannot be converted to a fraction. Moving on to our next question. So we're still talking sum, which means to add. We want to know what happens when you take a rational number and add it to an irrational number. So rational numbers are all those nice numbers, including repeating decimals and terminating decimals. So let's take the rational number of, let's say, let's go a terminating decimal 0.4, 40 cents. And let's add that to an irrational number. Remember, irrational numbers really break down to two things. It's always pi, icky decimal, non-repeating, non-terminating, and icky square root. So all square roots that never stop, never repeat. So let's take an icky square root, maybe the square root of this time 11, square root of 11. So we take the square root of 11 and I add it to 4. Go ahead and type that in your calculator. The question is, do I get a super icky decimal? No pattern, doesn't stop, non-terminating, non-repeating. And if that's the case, then you definitely have an irrational number. So going ahead and checking that out, 0.4 plus the square root of 11 should give you an icky decimal, which means it's irrational. Okay, moving on to the next example. What about if we multiply two rational numbers? We're talking products down here, which means to multiply. So looking at this, rational times rational. All rational numbers are nice ones, so I can take a rational number like 1/2 and multiply it by another rational number like the square root of, let's say, 16. So if I go ahead and type that in my calculator, you can put parentheses around that. Some of you can mental math that. Go ahead and give that a shot and see what you get. Okay, so we end up having the square root of 16 is 4. When we type that out in your calculator, you would have gotten a 2 or through mental math. Is 2 considered a nice number in math? Yes, for sure it is. So when you multiply two rational numbers, you end up getting a rational. We're just confirming that using our calculator. Next problem down here, an irrational multiplied by an irrational. So let's go ahead and take some icky square roots. Let's take the square root of maybe, let's take the square root of 8. Not a nice square. Icky decimal there. And let's take the square root of 3. So take square root 8 times square root 3 and check in your calculator, are you getting a terminating decimal, a repeating decimal, or are you getting an icky decimal? No termination, no, does not repeat. Go ahead and type that in. Square root 8 multiplied by square root 3. What happens when you take two irrational numbers and multiply it? You shouldn't say that you got an icky decimal there. So that means you have an irrational number, non-terminating, non-repeating, never stops, no pattern, ick. But this is the one time that there's an exception. So every time in math, we always teach these the way it always is, but then we're like, but there's an exception. So there is an exception. This one is a little bit tricky, and the beauty is you get to use your calculator anyway. At any point in your mathematical journey, you would be able to use your calculator on rational, irrational problems. If we tried another example down here, there is special occasions when this actually turns to a nice rational number. So check this out. If I were to take square root 5, which is irrational, square root 5, put that in your calculator by itself, it is irrational, and I multiply it by the square root 5. Multiplying by itself, square root 5 multiplied by itself, which is square root 5. Because of inverse operations of that power, go ahead and type that in, square root 5 multiplied by square root 5, and see what happens with the decimal there. So everybody should be typing in square root 5 multiplied by square root 5. And you get really the square root of 25. And we know the square root of 25 just means that we have a square that has the area of 25, What's the side length of that square root? And we get this nice whole number 5, which actually does become a rational number. It's a super nice value. So the tricky part about this is the only time there's an exception. When you multiply an irrational by an irrational, depending on the problem, sometimes our answer is irrational. And here's what's tricky. Sometimes our answer is rational. Now, you don't have to memorize that because it would be your job to make sure you can access that in your calculator. You know how to find the pattern there. Okay, so moving on. What happens if we take a rational multiplied by an irrational? Now, keep in mind that rational numbers are any nice whole number, any nice negative number, fractions, terminating decimals, repeating decimals, nice square roots. So let's take a rational number of -4, just a nice integer. That's a nice number multiplied by an irrational number. So any icky square root will work in pi. So let's use pi this time. -4 is a rational number multiplied by pi, which is one of the two irrational categories. Irrational is always either pi or icky square roots. When we type that in your calculator, go ahead and type it in. Look at the decimal. Does the decimal have any pattern to it at all? As you're looking at the decimal, you should see, no, that's an icky decimal, which means it is irrational. No pattern, does not stop, icky decimal. Okay, a couple left down here, guys. So let's go ahead and use our calculator to summarize what we have down below. So what happens if we take 2 and multiply it by 1/5? Go ahead and type that in your calculator exactly how you see it. So 2 multiplied by 1/5, when you do that, you end up getting in your decimal, in your calculator, 0.5. Or pardon me, 0.4, like 40 cents. That is a super nice decimal. It's a terminating decimal, rational number. Go ahead and multiply square root 6 multiplied by square root 3. When you do that, you get the square root of 18, which is a super icky decimal. No pattern, does not stop, so you should be saying I, irrational. Okay, next one, square root 3 multiplied by square root 12. Everybody should be typing that in. Okay, square root 36. Notice on this particular one, irrational times irrational gives us a nice whole number of 6. That one's a nice one, rational. Couple left, guys. Here we go. Multiply this one out. 5 multiplied by the square root of 2. Make sure you use parentheses there so you don't mess anything up as you're inputting the values. So when you type that one in, you should be checking to see, do I get a nice decimal or an icky decimal? You should definitely see an icky decimal there. No pattern, doesn't stop. Therefore, this one is irrational. Okay, 8th grade, 2 left. Here we go. Next one, notice it's a sum. We're adding this time. It doesn't matter because you're just inputting into your calculator just to see what happens as we input. I recommend using parentheses around those square roots. Go ahead and give that a shot. Square root 7 plus square root 7. Okay, you should end up getting an icky decimal there. No pattern, doesn't stop, irrational. Last problem, go ahead and type that in. I recommend using a parenthesis again over that last square root so nothing gets confused there. As you type that in, guys, check to see that decimal. Is it a nice decimal or is it an icky decimal? No pattern, doesn't stop. You should be getting another icky decimal. No pattern, doesn't stop. So therefore, it is irrational. So for summaries today, in summary, rational numbers. We take a look at rational numbers. We're really talking about nice values, like nice whole numbers, anything that can be written as a fraction a over b or manipulated into a fraction. It might not look like a fraction when you're first given it. Like a mixed number doesn't look like a fraction right away, but we can convert. Or a whole number can be written as a fraction. All super nice square roots work. Repeating decimals work. Terminating decimals work. Go ahead and write those down, guys. Repeating decimals, terminating decimals, whole numbers, fractions, nice square roots. And the beauty is that irrational numbers are actually easier to find, in my opinion. So all icky square roots are irrational, and pi. Those are the two major categories where you get this super icky decimal. No pattern, doesn't stop. Therefore, it makes it irrational. I'll go ahead and let you catch up on those notes, separating rational versus irrational, and then we'll talk about what homework is. Okay, guys, so for your homework tonight is to sort through rational versus irrational. You will need to be able to use your calculator to do that. Your homework is to get through just page 7 tonight. Just page 7 due tomorrow. Make sure you really have an understanding. Is it icky decimal or not? Icky decimals, no pattern, doesn't repeat, are irrational. Have a fabulous night. Just page 7.